All right, so today we're in our next lesson, solving inequalities using multiplication and division. And like we just said, we solve inequalities the same way that we solve equations. So you're going to see a lot of similarities here. All right, so we're starting off with division being connected to our variable. All right, now does anybody remember, how do I get my denominator out of the fraction? I need to get x by itself. How could I get that 5 in the denominator to cancel out, Zoe? Yes, multiply by the reciprocal. Now, it's not the full reciprocal. We don't want to put x on the bottom because we want x to stay on that side of the inequality. Okay, so now x is less than or equal to, but whatever I do to one side, I have to do to the other side. Okay, so negative 3 times 5 is negative 15. All right, now be careful on your number line. All right, especially with those negatives. Negative 15, which is our solution or our cutoff value, goes in the middle. What number is 1 unit less than negative 15? Farther away from 0? Negative 16. What value is 1 unit more than negative 15? Negative 14. Now I need to decide if it's going to be an open dot or a closed dot on my timeline, my number line. My inequality symbol tells me if it has the equal to part underneath the symbol, it's going to be a closed dot. Okay, closed dot. And then my arrow is going which way? My arrow is going to the left towards the 16. And here's what it shows, guys. Okay, now this is the part that I need you to understand because I'm going to ask you some more in-depth questions about the solution. All right, so here's where we need to really understand what the number line is telling us. Paying attention? Okay, this tells us that all numbers, not x just represents something. Okay, it's all numbers less than or equal to negative 15 will make this inequality true. Okay, so give me a number less than or equal to negative 15. Give me any number. Negative 15, negative 16, negative 17, negative 20, negative 25, okay? So those values are solutions. So is there only one solution to this inequality? No, there's a cutoff value. And anything less than or equal to this number, if I plug it back in, will make the inequality true. All right, so let's test one. Negative 20. Do you agree negative 20 is less than negative 15? So let's plug that back in, and you can do this mental math. All right, I just want to kind of show you guys what this looks like. All right, so what's negative 20 divided by 5? Negative 4. Is it true that negative 4 is less than or equal to negative 3? Is that a true statement? Okay, so what I've just done is I've proven that any value less than or equal to negative 15, if I plug it back in, makes the inequality true. All right, we'll dig a little deeper in a minute. Okay, let's look at the next problem. What do you notice about my next problem here?
Backwards.
Okay, it's backwards. If I read it left to right, this looks like a greater than sign, does it not? But it's not a greater than sign. Pay attention. It's not a greater than sign because I must read my variable first. This means all numbers multiplied by 2/3 must be less than negative 3. So instead of trying to read it backwards, why don't we rewrite the inequality so I can just read it forward? All right, so it's going to be 2/3 p. Do you see how it's closed off towards the 2/3? You see how it's closed off? So when I rewrite it, my symbol still needs to be closed off towards the 2/3 p. Okay? And then negative 3 goes on the other side. All right, so we kind of just talked about this. I want you to figure out what you need to do to get P by itself. All right, let's see. Katie. Doggone it. Emily. I'm sorry. Okay, Emily, what would you do to get P by itself? What do you think?
Divide by 2/3.
So if I'm dividing a fraction, what am I actually doing? KFC. So what happens to that fraction? Flip it and multiply. Okay, so to divide by a fraction is the same thing as the KFC method. Now, does everybody see how this all cross cancels now? So that's awesome. That's what I want to happen. Okay, so is my answer P is less than -3? No, because what do I need to do now? Do the same thing to the other side, times 3/2. Is there anything I can cross reduce?
Nope.
No, so now it's going to be P is less than, yes, -9/2. But that's going to be a little goofy to plot on a number line, don't you think? Like a fraction. So either change this to a mixed number or to a decimal. Okay, so if I change it to a mixed number, it's -4 with 1 left over, or -4.5. Either one of these makes it easier to put on a number line. Would you agree? Okay, so now that's my middle value on my number line. All right, -4.5. Now, your values to the left and right don't have to be decimals. As long as it's less than -4.5 and greater than, you're okay. So what's my next integer less than -4.5? What would be my next integer? -5. That's fine because it's still a value less. And then what goes on the other side? -4. All right, now we need to go to open dot or closed. What do you guys think? It is going to be an open dot. And which way would my arrow go? To the left. Very good. Okay. All right. So any questions on that? Any questions on my first two? All right. We are going to skip the next one, the n/3. What would I do to both sides to solve that one, guys? Just tell me. Multiply both sides by 3. N is less than 3. Okay. Now let's come over here to this next one. -0.5 is less than or equal to m/10. But is this actually a less than or equal to sign? Is it? It's not, because my variable doesn't come first. So I'd like you to rewrite it, okay? So now you can truly see what sign that it is and see if you can solve it. All right, I'm just going to give you guys a minute to see if you can work ahead. Does anybody want to read me the inequality, how you rewrote it? Anybody think they got it? Michael, I can see it in your eyes. I can tell you got it. All right, what'd you say?
10/1 times.
Well, before you even do that, how did you flip it around? You,
Over 10 is greater than or equal to -0.5.
okay, perfect. All right, did you guys do that? Is it open towards the M? Okay, then what did you do? Now we're on the step you were talking about.
Then you times 10/1 times 1/10.
Good.
And then you get m is greater than or equal to -0.5 times 10,
Which is?
which is -5.
-5, very good. Now on your number line, would it be open dot or closed dot?
Closed.
Closed, and which way would your arrow be going?
Right.
To the right, great job. Okay, so we're not going to graph that one. Okay, so now in example 2, we just have a different operation connected to our variable. Okay, so now it's multiplication, which means I need to divide. Okay, so again, this is really similar to the way that you guys solved equations. All right, so we do the inverse operations. All right, so y'all just tell me, what would I do to get x by itself for 6x? divide both sides by 6. Okay? If I divide both sides by 6, x is greater than negative 3. Okay? And then we would graph it. Would it be an open dot or a closed dot? Open. And which way would my arrow go? To the right. Okay? Now I want you to do this next one on your own. Okay? So obviously we're seeing a pattern here. All right? It gets tricky when my variable comes after the symbol. Because when I first look at this, I think this is a less than sign, but it's not. Okay? Because I always have to read my variable first. So try to rewrite it and then solve for Q. All right, so did you say 2.5Q is greater than 15? Did you guys say that? Okay, so it was still open. Now what do I divide both sides by? 2.5. All right, did anybody do that division yet?
Yes.
Q is greater than what, guys? 6. And that would be an open or closed dot on 6?
Open.
Open, arrow going to the right. Okay, to the right. All right, so we have an exception here, and we'll kind of end here. We're going to work a couple, and then we'll stop here for today. We solve inequalities the same way as equations, except when a negative integer is connected to the variable by multiplication or division. My rule says that I must reverse the inequality. So if it was greater than, now it's going to be less than. And that's because of my rules for multiplying negatives. Okay, I'll show you what I mean. So does everybody see that negative 2 is connected to x by multiplication? Okay, if it was connected by addition or subtraction, this does not apply. Okay, because it's multiplication, I must divide both sides by negative 2 to solve. So x is greater than what?
6. Negative 6.
Negative 6. Okay, but because I had to divide by a negative, it's not greater than anymore. It is now less than. I must reverse my inequality. Okay, I'm going to prove it. I'm going to prove why this works. Give me a value that is less than negative 6. Give me a value. Negative 7. Okay, let's just start at negative 7 or negative 8. Okay, so what I'm saying is all numbers less than negative 6 would make this true. So you said negative 7. So let's come back up here. What is negative 2 times negative 7?
Negative 14.
Times, no.
Positive 14.
Okay, positive 14. Is it true that positive 14 is greater than positive 12? So if you had not switched your inequality, you would have said the number had to be greater than negative 6. And then when you plugged it in, it would not have made the inequality true. This is because of your rules of dividing a number by a negative or multiplying by a negative. Okay? So it's going to take a minute, all right? If I explain it again, it's not going to clear things up anymore. You need to hear it once, and then we'll keep working on it, okay? Has anybody ever done that? You just kept repeating yourself to help someone understand, but they didn't really understand any better? That's kind of what we're facing right now, okay? Okay, give me a sec. All right, let's do one more, and then we'll be done for today. Let's do one more. Negative 4x is less than negative 12. Negative 4x is less than negative 12. All right. So I see some of you already starting to work. Elizabeth, what do I need to do to get x by itself? Divide by negative 4. Now I need to make something really clear. Just because 12 is negative, that's not why I reverse my inequality. I reverse it because there's a negative connected to x by multiplication, okay? Which is going to mean my multiplication rules to check it. So divide both sides by negative 4, and x is greater than positive 3. Okay? I had to reverse my inequality because I divided by a negative. Let me show you why that works.
You need to graph it.
You will graph it, okay? But let me show you why it works. Okay? Give me a number greater than 3.
4.
4, okay? So negative 4 times positive 4. I'm testing a solution. Would that be less than negative 12?
No, it'd be more.
Yes, negative 16 is less than negative 12.
Oh, yeah.
So if I had not reversed my inequality, because of my rules of multiplying a negative, I would have got the wrong answer. Okay? My answer is x is greater than 3. Now, you will not have to show this on this part on your test, but I'm trying to help you understand why you have to flip the inequality. All right? Because I know that that's a little weird. We'll keep practicing this more tomorrow, okay? But for today, this is where we're going to stop. You can start your homework tonight, guys, but please do not submit it because we still need to do all your modeling real life questions tomorrow, okay? So tonight, your homework is not due tomorrow. I've already deleted it from the grade book because the end of the quarter is tomorrow. So you're not even going to see that in the grade book, and we're pushing that homework to be due on Monday. All right, that's everything you need to know for today.